but very excited to be here today and talk to you about why your AI coding tools aren't saving your time. Just to start, to get us all kind of warm up, it is early here in California, so let's get some engagement going. So we're going to be using the comments on a StreamYard for all of these things. So let's start easy. We'd love to know where are you joining from. I took a peek at the sign up list early this morning and saw there was people from a lot of different places. I'm in Oakland, California. Not sunny right now. Foggy, somebody California. But where are you all calling from? Colorado, Los Angeles, Alameda, New York, the Netherlands. Very cool. Kansas City, Washington. We're covering a lot of time zones. Valladolid, Spain. Nice, nice. Now even more than just the US. This to me is one of the coolest things with the internet and online culture is this chance to interact with people in a lot of other places in the world. Very excited. So let's get started. So today I wanted to show you three tasks that I've been putting up for weeks in one of our flagship demo applications, and how the use of AI has really enabled me to accomplish a lot more than before. And if you work at startups, you know that there's always tasks, or anywhere for this matter. There's always tasks that you're putting important, but you're not doing because of lack of time, because of lack of resources. And I find that AI is a great source for that. We are in this big shift of every company adopting AI tools, but there has been challenges. AI tools today stop short of real productivity. We see this papers, reports of companies adopting AI, but then don't really gaining the all the improvements, the velocity changes they were expecting. And to me, one of the main reasons for this is that AI tools give you smart suggestions in a vacuum. When you're using something like Copilot or even Cloud Code, especially if you don't take the time to set up MCPs and other things, you're getting great um, text suggestions, but these have nothing on your application, on your infrastructure. So you're just getting code that looks good. And the problem with this is that once you put that code in a staging, in production, you're going to have to spend hours validating if the code works. And this pretty much cancels out all the productivity gains, because yes, you're much faster at writing code, but if you have to spend more hours than before trying to figure out if that code works, then what is the point? What is the benefit for all of us? We've been working on this space for a while, and as we've been using AI internally and building products in the space, um, we've come to the conclusion that for AI to work, AI needs the same tools and the same resources as human developers. It's easy as that, right? Like if a developer writes code to read and write from a database, and it has no database to try things on, the code's not going to be great. But if you give the developer a database, unit tests, data, the likelihood of that code working grows exponentially. And the same happens for AI. Especially right now, when we're in this transition period. I believe that AI truly needs the same tools and resources than human devs. So before we get deeper into this kind of hot take and why we think that's the case, let's do another quick round on what AI tools are you using today. I'm using Copilot, I'm using Cursor, I'm using Cloud Code, I'm using Octero AI. But what are you using? Drop your comment on the comment section of the StreamYard. ChatGPT, I'm seeing Claude. Granola, yes, I agree. Granola is probably one of my favorite AI tools. Not for coding, but they're great for meeting transcription. This is not a sponsored post, but if you take a lot of meetings, check out Granola. It's a fantastic addition to your, I call it kind of my off-board memory. Genesis AI, interesting. That's a new one. I haven't seen that one before. I have to check it out. So we're seeing a trend here, right? As expected, we're hearing a lot of Copilot, we're hearing a lot of Claude, a lot of ChatGPT, and these are, make sense, no? These are the most used tools out there, are the tools that are getting the most attention. They're early movers, and they work really well. So what I think is the missing ingredients, we're going to talk about the missing ingredients for what I call production ready code. And for me, production ready code means agents generating code that I trust enough to put in production. Not code that looks good and then I have to do all this extra verification, deep review, analysis, but no, code that I feel comfortable enough to just have it go to production. And the first missing ingredient that I see all of these tools, Copilot, ChatGPT, Claude, are missing is context. Context is a fairly overloaded word, especially in the world of AI tools, because when we talk about context, most people think about code. And that's very important, right? You have to load the code in the context, make sure your AI agent or your AI tool understands your code base so it can generate meaningful suggestions. However, we shouldn't stop just at context. One thing that's very important is to give your agents access to real environments. It is amazing how different the behavior of an agent is between just generating code to being able to generate code, deploy it somewhere, and then see the results. So for me, that is kind of like the first meaningful change is giving access to a real environment. And this means deployment tools, this means tests, this means data. So when you're thinking about the context that you want your agent to have, remember, it's not just about the code. Think about how can you give your agent code? How can you give your agent access to meaningful infrastructure, build tools, test tools, data? Because as you give the agent this more complete view of what your application does, how it runs, how it looks like, you're going to be getting way more meaningful suggestions. The second missing ingredient that I see on a lot of in our community, a lot of our customer setup is infrastructure. I think it is very important, once we go from just having an agent that knows about our code to having an agent that has a full context of our application, it's very important for this to be able to have access to your infrastructure and to be able to run safely on your own cloud account with your own policies. To me, this is number two. And this maps is similar to what we've seen with dev environments for many years, right? Having a realistic dev environment beats having a local simulacrum. And the same thing happens with agents. You don't want your agents to take your code and deploy it somewhere you have no control, no? A VM in someone's cloud account, in some data center. No, you want it to be on your own cloud because that's where your applications run. So you want them to run on infrastructure as close to your application with the same policies, with the same security boundary, and all of those things. This is also very important because we go back to the same concept, right? You want the agent to be able to, as part of the evaluation cycle, get meaningful feedback on whether the application is running effectively. And you're only going to get this meaningful feedback if you run it on your own cloud infrastructure, on your own policies, with your own deployment scripts, and all of that. Number three, and if you get something out of this webinar, is please take this slide, and is the importance of giving your agent sandboxes. If they're local or remote, that is a different conversation. I prefer remote because I think they're safer. But it is very important when you define your AI agent strategy to have some sort of, or a context of, a dedicated environment for every agent. You don't want your agents to just run on your local machine, having access to your identity, to your credentials, to your secrets, fighting over the same resources, fighting over the same file system. I know there's techniques out there. Git Worktree is becoming very popular as a way to handle some of the situations. But I do believe that it makes a huge difference to have a proper sandbox where every agent is going to be immune to crosstalk. They're going to have their own repo, their own file system, their own dedicated resources, a way for them to not be impacted from whatever the other agents are doing. And more importantly, to ensure that they're not leaking secrets. Cloud Code, for example, now supports this natively, where you can define a sandbox. They're using the dev container format, where you can define which tools they have access to, which endpoints they can hit, firewall rules, and it makes sense, right? Because agents today, by default, are going to be using your identity, which means that they can go, and this has happened, and there's been public cases of this. They can use your SH key to log into production and delete the database, or leak your SH key into a public place or a secret and expose you to a hack. So remember, sandboxes are very important. First, from an access control state perspective, but also, and very important, from a security perspective. So when I think about AI agents and when I think of setting up the systems for ourselves internally, for our customers, for our community, I think of this framework as the way to get production ready code. You want a structured prompt, and that's very important, right? Do spend time practicing your prompts. We'll show you some examples today. Make sure your context includes infrastructure, data, tests, logs, not just code. Give your agents a safe environment where they can iterate, test, relaunch things without this having an impact on each other agents, and more importantly, on your production or other environments. And if you have these three things together, I'm pretty sure that you're going to get closer and closer to what I called production ready code. And this is very important because AI agents are such a accelerator, but it's not, there's no magic bullet, silver bullet here, right? You do have to put the work to enable them to help you. The same way that when you hire someone in a team and you want to, they're not going to be effective just because you hire them and they show up. They need to get the right enablement. AI agents also need the right enablement. And in their case, when I'm thinking now of this new phrase of agent experience, I'm thinking of this: a good prompt, access to a complete context that includes code, infrastructure, environments, builds, tests, data, all of those things, and a safe sandbox. And this gives you, I guarantee you, way better results than if you just have an agent that has access to your code base. So, as we promised on this webinar, I wanted to use today to show you some practical examples of this. We're going to be using our upcoming Octero AI feature, but the webinar is not about our feature. The webinar is about production ready code. So I'm going to use this to illustrate these 3 points that I was talking about. So focus on that. Of course, if you want to try our new AI feature, reach out. Happy to hook you up with early access, but let's focus on the framework and the 3 pillars to get production ready code. For today's demo, I'm going to use the Octaco Shop, which is one of our flagship demo applications. I like using this application because it's I think, a good example of what a small cloud native application looks like. It's a demo that I have been developing over the years and adding more and more features. And at a high level, this is what it looks like. It has 3 microservices, one for the menu, you take the menu, one for the kitchen, you prepare the food, and one to prepare the check. Each of them has a different programming language. Menu is Node, kitchen is Go, and check is Python. All of them run on Kubernetes, and they use SQSQ and an S3 bucket to store data and for transactional information, and this runs on AWS. The Kubernetes stuff is deployed on Helm. AWS is deployed using Terraform, and you'll see why this matters in a second. So for the first demo, and this is a real use case. When I demo Octero, when I demo Taco Shop, one of the things that I was lacking on my demo was, and if you look at this diagram, was a database. We at Octero have a lot of data related features, so we wanted to put some data in it. So the first thing I did, and going back to the importance of a good prompt, is I wrote a prompt like this. I've been trying different styles, so now I'm going to this larger prompts where I explain what I want, I give it a context, what environment, the application, state, my goal, and then some requirements. In this case, I want a prompt, an environment. I want a prompt that will give me a Postgres database with a dashboard, with the real-time statistics on the orders of the restaurant and most popular food items. So I like putting them on Markdown. I'm gonna take the Markdown of my prompt. I'm gonna copy this, and in this case, I'm gonna go to my agent. I'm gonna paste this prompt as is. You can see this is a more complex prompt than just saying, "Give me a dashboard." I am going to indicate the repo I want this to work on because I want my agent to know about where my repo is, access to infrastructure, as we're saying, all those things. And I'm going to click here to have the agent run. I deployed this agent before. You can see I have a bunch of agents running. I'll get back to it in a second, but you can see it here. And what this agent is going to did, and this is part of what we automate, but it's kind of what you should do if you want to build this on your own, is the agent, the feature of Octero deploys an agent on our cloud infrastructure on Kubernetes, deploys a copy of the application, and then as the agent starts to go over the code suggestions, it will iterate on the existing application until it gets a point that says, hey, this works, all your requirements have been fulfilled. You can see here, Octero is powered by Cloud Code, so it's the same as running Cloud Code locally. You can see all the planning, the iterations, and the output. But what I show you here that I think is super useful is that here you can see that I have all these links to the application my agent deployed. If I go here to this link on check dashboard, you can see it here. You'll see it's going to take a second for this to wake up. I ran this demo last night, and Octero put it to sleep to save me money on infrastructure. But what you're going to see here is that the application is going to be up and running. And let's give it a couple of seconds. In the meantime, I'm going to go back here, click on the editor to see the code real quickly. But you can see that here, the agent added code for database management. It updated my Docker file to add this Python code. It modified my dependencies. It changed my code on my Kubernetes manifest to change the configuration to pass a database URL. So as you can see, all of this starts to look more than simply code suggestions. This is an agent that knows about my requirements, knows about Docker, knows about Kubernetes deployments. And what I wanted to show you, let's see if it's loaded now. It is loaded now. You can see that it's giving me a running application. And this is what I was talking about with context, right? At this point, we know that the agent understands the code base, knew how to build my application, deploy it, ran some tests, and made sure that this code actually works end to end. And to me, as a developer, this gives me a lot more confidence because this is not just code that I need to then go and look at a pull request and try to make sense of it, right? Like maybe in isolation, if I'm looking at this, it says, hey, this looks good. But for example, imagine the agent didn't add these new files to the Docker file, then my application would fail on deployment. But because this agent has been fed with all of the context, it has access to my infrastructure and all of those things, it was able to give me a much more meaningful suggestion to the point that here I could just say that the agent say, hey, looks good. Open a PR and then have this code go and keep and proceed with my CI/CD pipeline. And again, that's to me is what's very valuable about this. Real quick, we have a second example. This is a more complex prompt. This is a prompt where, when I build this demo, I made this very, don't blame me for this, but I took a shortcut and I added a single secret for all microservices. They're all sharing the same cloud credential, the same access control, which is bad. No, ideally, every service should have its own secrets and all of those things. So I've been putting it off. I knew it was wrong, but I was like, hey, it's a demo. It doesn't matter. But it matters, right? Like it looks bad and it kept bugging me. So the other day I was like, okay, please, I need to fix this. I'm going to have the agent do it. So I spent a few minutes writing this prompt. Again, very clear prompt description, context, requirements, and expectations. And the same, I copy this prompt, I launch it here, and the agent very efficiently, you can see here, created a solution for me. And in this case, the agent updated my Terraform scripts to create a role, a set of keys, and a user on AWS for every service, modify my Kubernetes configuration to pass a different secret for each microservice, modify the code to read this secret, to use ambient credentials that were coming from the secret rather than hard-coded AWS keys. And it gave me proof that it worked because now I have, same as example before, a running copy of the application. So again, this agent, I'm able to trust the code that the agent generated more because it has all this context. It has access to my infrastructure. It can build, it can test, it can deploy. So at this point, I know that this Terraform change that I was kind of afraid of doing for a while. I was kind of like putting away, part busy, part because I didn't want to deal with this kind of like level of configuration. But now that I have it here, I have way more trust on it than if I had just run it, imagine on Copilot, and just said, hey, modify this Terraform. I'm sure that whatever Copilot suggested would not have worked out of the box, probably had a bunch of different issues. But here, because the agent has access to the infra, the deployment technology, in this case, an AWS account, a Kubernetes cluster, it is able to make much more meaningful suggestions. And that is the value. And that is how I see that we need to evolve as we think of AI agents. It's no longer about just giving them code. It's also about giving them this richer context so that they can make better suggestions and better verifications. The third benefit of this, and you can see it here that I was talking about our framework, is isolated sandboxes. Each of these agents is running its own instance of Cloud Code on a different sandbox, in our case on Kubernetes, but this could be anywhere. And you can see that each of these agents was able to work on a different facet. I was working on this last night. I went a bit crazy, started like finding issues or had ideas on how to improve this demo. And you can see I started to launch agents to do separate things. This agent, I asked it to create a Claude MD file. This other agent, I asked it to fix all my dependencies and CVEs. We have the agent that built the dashboard. We have the agent that added a navigation bar. At some point, I found a bug on how we're displaying the orders on the UI. So I had another agent fix that. So you can see the value here because I'm able to run multiple agents. Every agent can have its own copy of the entire context. They're not fighting each other against resources. They're not fighting each other for the same application. I don't have to issue magical Git work tree commands. It just makes my life easier and allows me to trust the output of the agent even more. So just to wrap this up, and I hope this kind of is opening your mind, inspiring you to try new things with our agents. But to me, the impact of following this framework is simple. I can trust the output of the agents more than before. I have to spend less time validating and thinking about it. And to me, trusted output leads to increased productivity. I can do a lot more. I can ship more features. I can think at a much higher level because I can trust the output of my agents. And it's not for free, right? It's not just because of the agent magically works. It's because I'm applying this framework where I'm having structured prompts. I'm feeding my agent with a lot of more context than before: code, access to infrastructure, builds, tests, data, all of those things. I'm providing a safe, scalable environment where every agent can run unbothered by all the other agents. And these three things together are giving me more confidence, and this leads to production ready code, and this leads to increased productivity for, honestly, in our case, for the entire team. We're applying this. These are real use cases. This is a demo I use every day. We're doing the same thing for a lot of our internal features, and we're seeing a vast improvement in velocity. This is real, and I hope you can use this and go back to your teams and start applying some of the ideas that we discussed this, and to gain more velocity out of your AI investments. If you're interested, what I show you today is an upcoming feature, Octeto AI. Octeto is a secure way to build with AI agents. Learn more at octeto.com/AI and reach out if you want to get early access to this feature. It's coming up soon, but we can always use more feedback. And with that, I want to thank you for your time. Thank you for your attention. I really hope this will inspire you to go and improve your AI workflows. But before we leave, we have a bit of time for questions or any comments. Anything you want to share with the audience? Let me look at some of the questions we have on StreamYard. So we have one question that says, what happens when an AI agent fails or makes a mistake? Can you debug what went wrong? Yes. In the case of Cloud Code and in the case of Octeto, which at the end of the day implements Cloud Code, you're going to see all the steps there. So for me, one of the coolest things about these remote sandboxes is that because every agent has a sandbox, it keeps a state, you can pause execution at any time, go there, see the code, see the application, see the state, and if anything looks kind of funky, you can just kind of tell the agent, hey, I don't like this, try this other thing instead. Or if you see the agent getting to kind of like a dead end, destroy and restart. Because it's running remotely on a sandbox, you're going to lose local configuration. You don't have to spend time resetting a state. That to me is another kind of side benefit of this kind of idea of remote sandboxes. Have time for a couple more questions. Any tips for picking the right infrastructure for a project? That's a good one. I'm biased here. I like Kubernetes. I've been using it for a while. And I like it because it allows me to spin up infrastructure very quickly. These demos you're seeing here today, all of this is running on a small Kubernetes cluster. It has 5-6 nodes running on GCP. So I like it for that. I particularly like Terraform for cloud infrastructure because it's a standard. And Helm or any other cloud native infrastructure for Kubernetes. Both are broadly available, they're well understood, and all the models have vast training on these technologies. I think something newer or more bleeding edge, while cool, it might be hard for the agent to figure it out. We have another question on, could you share your prompts? Yes. So the prompts are, we'll send you a link. The prompts are on GitHub. If you go to Octeto, GitHub.com. Actually, I'm going to share it on StreamYard. If you go to our repository for this particular demo, there is a docs folder, and I merged the prompts yesterday. So I have some sample prompts. Each of this is the prompt that I use to accomplish what I showed on the demo today. I'm going to show it right now on the comments. And I think I messed it up. Yeah, I messed it up. The second is the real one. I missed a T. And James, you're saying, I'm seeing support for AWS at GCP, but I'm moving into Azure. We support the same. Like Octeto supports AWS, Azure, GCP. There are also, if you're using Cloud Code directly, there are MCPs for all of these clouds. I believe at this point, all of those three are very well supported. In our product, we support them all at the same level. We have a lot of community members using Azure, GCP, and AWS. I would say almost equally. And I think that's it. Thank you so much, everybody, for your time. Thank you for your questions. Thank you for your patience at the beginning. I know we had a bit of a technical snack, but I'm glad that everything went well at the end. And please continue experimenting with AI. It's a brand new technology. It's very exciting. We're all learning together. So as you experiment, as you find things that work, share them with your peers, share them with the community. It is fascinating how fast this is changing, and how powerful it's becoming. So thank you, everybody. We will send a follow up with the prompts and with some other information, but thank you for your time and hope you have a great rest of your day.